problem if it wasn't prefix free.
Mm-hmm.
If it wasn't prefix free, you'd basically need NDFAs.
Right.
Because every time you'd reach an accepting state, you'd have to be like, okay. You don't need to think like all the time, am I on string A or string B, right? Because we're
Right.
trying to decide if our string can be split into two strings, one in A and one in B, right?
Right.
So for any regular languages, if you're talking about general regular languages, basically every time you take a step, you're like, every time you reach a accepting state,
Right.
you need to be like, is this where we split off and go to B?
Right. Right.
And then you would need to be running kind of like two parallel computations,
Right.
Which is what NDFAs are good for, though of course you can convert them.
Right.
Where one is like, okay, let's say, sure I'm in an accepting state of A, but let's say I stay as a string from A longer.
Right. Right.
Maybe it's like the second time I hit an accepting state that I'm going to transition to B.
Right.
And then, the parallel process from the first accepting state is going to be like, okay, let's say that's where we split it.
Right.
Now I'm going to see if the rest is in B.
Right.
What about 3B makes this easier?
Is it that if you get to an accepting state, you know that you're at the end of A, and you can just
Yeah, exactly.
B?
If you
Right.
hit an accepting state, there's no way your string is in A if you add anything else.
Right.
By the property from 3B.
Right.
So actually, whenever you hit an accepting state in A,
Mm-hmm. Yeah.
like let's say this is the machine for A,
Mm-hmm.
it can have multiple accepting states. You just can't get from any of them like to any of the others, right?
Right.
As soon as you leave here,
Mm-hmm.
you're not in A.
Right. Right.
So splitting later is no good. It just does not help you. So if this is not where you split the string, then this string is not in A concatenated with B.
Right.
Right?
Right.
So now we move from these. Let's make this the machine for B, and this is B's start state.
Mm-hmm.
These are just going into the start state
Right.
of B.
Right. So do you right.
And this can be a general regular language because we just hang out here for the rest of the consideration.
Right. Is this so yeah, this is like another is this do we have to use like an epsilon move to get from the final state of A to the start state of B, or can you just map take that last
You just
delta?
what you do is you make a transition so let's say the alphabet, so basically this is any character in the alphabet. It's just some single alphabet character. Mm-hmm. So basically, you take whatever transition functions used to be coming out of these accepting states and going somewhere else
Mm-hmm.
that we know isn't going to accept. You cross them out, you just ignore them,
Mm-hmm.
and you make new transition functions from the accepting states of A
Mm-hmm.
to the start state of B.
Okay.
That you make one for every element of the language. It doesn't matter what the next character is.
Oh,
You want that to be...
Right.
Actually, you're right. So you don't want to go to the start state. You want to go to the next state.
Okay.
That's a good point.
Yeah.
Because otherwise you're like wasting a character, and that character
It's
should be
offset.
considered
Yeah,
as the
right.
first part of B.
Right.
So actually what you do is you treat these as like start states of B. Like for the purposes of the transition function.
And we know that you can't just end simpliciter in a final state because of what we just talked about with because then the final state would have to refer to itself, and that screws
Right.
up the whole thing.
Yeah,
right?
yeah.
So it's always going to go somewhere that's garbage.
Yeah, it's always going to go somewhere that's garbage, exactly. So instead what we do is we substitute, it's not actually an epsilon, I apologize.
Yeah.
This is, okay, we can still have the start state of B, but let's say this is like 1 and this is 0 transition,
Mm-hmm.
and they go to these states in B, then we have a 0 transition here, and a 0 transition here. So those are both gonna start state of B transition. Right?
Mm-hmm.
And then 1 is gonna take you to where 1 should take you.
Right.
Here.
Right.
And will this one also go there, right?
Right. Right.
We still might keep we'll probably still keep the start state because
Mhm.
things can go. I don't remember how you guys defined it, but presumably things can go back to the start state.
Right.
Pretty sure they can in
It's
your
just simpler
definition.
to keep-
So if things go back to the start state, they should go here.
Right. Right. Cool. Yeah. This makes sense. This is what I was.
Also,
Yeah.
These are only accepting states anymore if B accepts the empty string.
Right.
So there's other ways to do this construction, but this is the way I'm doing it for now. But like, only start final states. Sorry. Only final states if actually I guess I could have just done final if what was it, epsilons, if empty set is in B, right,
Only final states of the concatenated.
of the concatenated machine.
Right. Yeah.
That makes sense?
I buy that. Yeah.
Cool. So that is 3.
Nice. Sweet.
You see though why this would have been way worse if this was not prefix free.
Right.
Yeah, that would have been terrible.
Right.
Okay, cool.
Yeah.
That's 3C.